So in the previous video, you learned what a chemical equation was. You learned what the purpose of balancing a chemical equation. You learned what three things do chemical equations reveal. And then you actually learned the steps for writing and balancing chemical equations. Well, in this video, you're actually going to get to practice those steps and apply that same amount of information. So remember, the ultimate goal of balancing chemical equations is to conserve mass or conserve matter. So that means matter cannot be created or destroyed. So what you start with is what you end with. You should have the same amount of atoms of each element on the left side and on the right side. So if you remember your steps, we start by writing out our symbols, which is done for you already, and then you're going to write under it your reactants and your products on each side. So the symbols for those are carbon, oxygen, and hydrogen in the first one, carbon, oxygen, hydrogen in the second one. So if you look up top, you have carbon dioxide, which is a gas, water, which is a liquid. You have C6H12O6, which is a glucose molecule, and then you have O2, which is oxygen gas. So we're going to start by finding that element that only appears one time on each side. So if you look up here, I see carbon one time here, and I see carbon one time over here. 6 atoms of carbon over here, 1 atom of carbon over there. So I start by writing down that information to keep track of how many atoms I have on each side. So I also have 2 atoms of oxygen here, 1 atom of oxygen here. That is a total of 3 on the left side. I have 6 atoms of oxygen here plus 2 atoms of oxygen there. That's 8. I have 2 atoms of hydrogen on the left side, or the reactant side, and I have 12 on the product side. So go back to the one that you start with, which was carbon, or we decided we're going to start with because it only appears once. So we need to figure out, how do we get the same amount of carbon on the reactant side as we have on the product side? So because I have 6 here, I have to think, what times 1 is going to give me a total of 6? So 1 times 6 is going to give you 6. So when I multiply what I currently have by 6, I'm going to get 6. So I no longer have 1 once I multiply by 6, I have 6. So the coefficient is the variable that you're going to put right there in order to balance the carbons on both sides. So carbon is now balanced. So now I want to go to the hydrogen. Hydrogen appears twice on the left side and 12 times on the right side. So I want to figure out, how do I get to 12 from 2? So you know that 12 divided by 2 gives you 6. So I don't want the 2 anymore. I want 12. How I'm going to get 12 is by multiplying by 6. So what's going to go in this blank here is the coefficient 6. So 6 times 2 is 12. I already have 12 on this side. So now my hydrogen is now balanced. So now I go to my oxygen. Well, I know I don't have 3 and 8 well, 8 still applies to this side, but I don't have 3 anymore because I've added some coefficients, and that's changed the amounts of oxygen that I originally had. So I can go ahead and mark this out. So when I added the 6 here to balance out the carbon, I also changed the amount of oxygen. So now I have 6 times 2, which is 12 for your oxygen. And I had 1 already over here, and now 1 times 6 is 6. So 12 plus 6 is going to give me 18. So I now have 18 oxygen. So I also want to get 18 oxygen on this side. I don't want the 8 anymore. But an easy way to do that, because we already know that we need to fill in this missing blank here, because if we add anything here, that's going to throw off what you already have for your carbon and your hydrogen. So what we're going to do is put a 1 here, so that we know that we don't need to do anything else with this molecule here. So because I have a 1 here, 1 times 6 is 6. So I'm going to do, what's 18 minus 6? That's going to be 12. So we have this 2 here. You should already remember from before, 12 divided by 2 is going to give you 6. So the coefficient that I'm going to put in here to make this whole thing balance is going to be 6. So now I have 1 times 6 is 6. 6 times 2 is 12. 12 plus 6 is going to give you your 18. So I now have 18 oxygen on the product side and 18 oxygen on the reactant side. Oxygen is balanced. So when you read this balanced chemical equation, you're going to have 6 molecules of carbon dioxide, 6 molecules of water, That's going to produce 1 molecule of glucose, which is C6H12O6, and 6 molecules of oxygen gas. So if you don't remember from biology, that is your photosynthesis equation. So in problem number 2, I have Na2O, which is sodium oxide. I have water here, which is H2O, it's a liquid. And then I also have my sodium hydroxide. Remember, hydroxide is a polyatomic ion. So I want to start by writing down what I currently have for the amount of atoms on both sides. So I have 2 sodiums on the reactant side, I have 2 oxygen, and I have 2 hydrogen. On the product side, I have 1 of each. So as of now, we want to figure out what can we do to the product side to get the amount of reactants on the amount of atoms on the reactant side. So we're going to start with our sodium because we know that it only appears 1 time. So we have 2 sodium on the left side. We're trying to get 2 sodium on the right side. So what times 1 is going to give you 2? And that is 2. So 1 times 2 is going to give you 2. We no longer have 1. We cross that out. So I'm going to write a 2 coefficient here because once I multiply by 2, I have enough sodiums on both sides. It is balanced. So 2 sodiums on this side, 2 sodiums on this side. Now we're going to go to hydrogen. I have 2 hydrogen on this side. And now that I've added the coefficient of 2 here, this coefficient is going to be multiplied by each one of these elements. So I have 2 sodiums, 2 oxygen, 2 hydrogen. So if I have 2 hydrogen now, that already matches the 2 hydrogen I had on the reactant side. So sodium is balanced, and now that I've added that 2 coefficient, hydrogen is balanced. So now let's take a look at oxygen. I have 1 oxygen here, 1 oxygen here. 1 plus 1 is 2, so 2 oxygen on the reactant side. Well, remember, this coefficient has now balanced this side because this 2 belongs to the sodium, the oxygen, and the hydrogen. So 2 oxygen on the product side, 2 oxygens on the reactant side. So now oxygen is also balanced. So what we can do to ensure that we won't put anything in these blanks and we understand that what is already here on the reactant side is fine, we add 1s. So when you read this balanced chemical equation, it's going to say that 1 sodium oxide molecule plus 1 water molecule is going to produce 2 sodium hydroxide molecules. So now we have an application problem. So if you notice, this is a word equation, and we're going to have to convert this word equation into the chemical equation, and then we need to balance the chemical equation. So liquid carbon disulfide is going to react with oxygen gas. It's going to produce carbon dioxide gas and sulfur dioxide gas. So liquid carbon disulfide is going to give you CS2 with the L symbol. Reacts means that you're going to use this plus symbol with oxygen gas. Remember, oxygen gas is diatomic, so you have O2 with the G symbol. It says producing, so you're going to use your yield symbol. Carbon dioxide gas, that's CO2 with the G symbol, and sulfur dioxide gas. So the and lets you know to use another plus sign, and sulfur dioxide gas is going to be SO2G. So after we've written our symbols, what we want to do is list the reactants and the products on each side, and then, because that's what you're seeing as your symbols are, then count the amount of atoms we already have of both elements, or all 3 elements on each side. So we have 1 carbon currently on both sides. We have 2 sulfur on this side. We have 1 on the product side. We have 2 oxygen currently on the reactant side, but we have 4 of them on the product side. So we still want to pick 1 element and that only appears on both sides 1 time, and then go from there. So we're going to start with carbon. Carbon is technically already balanced for now. So we're going to move on to your sulfur. 2 sulfurs on the left side, 1 sulfur on the right side. So what times 1 is going to give you 2? That's going to be 2. So we can cross out this because we no longer have 1. Once we multiply by 2, we're going to have 2. So that 2 coefficient goes here. So 2 sulfur atoms on the reactant side, 2 sulfur atoms on the product side. So sulfur is now balanced. So we have 2 oxygen on the reactant side, and we have 4 oxygen on the product side. So we actually need to try to get the reactants this time on the atoms of the reactants on this side to balance out with the atoms of oxygen on the product side. So what times 2 is going to give you 4? or 4 divided by 2 gives you 2. So you can use either one of those thought processes when solving this problem. So this 2 is going to go right here. So we're no longer going to have 2 because we multiplied by 2. You're now going to have 4. So 2 goes right here. 2 times 2 is 4. We already have 4 on this side. So now our oxygen is balanced, and we started out with our carbon being balanced. So remember, in those places that we didn't have to add anything, you want to put a 1. So the balanced chemical equation here is 1 molecule of carbon disulfide plus 2 molecules of oxygen gas is going to produce 1 molecule of carbon dioxide and 2 molecules of sulfur dioxide. So everything is balanced here. Now it's going to be your turn to apply this information. Good luck.